AI is reshaping industries at breakneck speed, consuming massive computing power. Traditional IT can't keep up. And as AI scales to meet enterprise needs, we're hitting roadblocks with unexpected costs, delays, and productivity bottlenecks. Something has to change. Enter containers and Kubernetes. These tools give AI the power and flexibility it needs to perform at scale. It's not about fancy tech, it's about staying competitive and cost-effective as AI becomes the norm. Well, Kubernetes is emerging as the go-to platform for AI at scale, but why? How does it handle the complex demands of machine learning models, data pipelines, and inference services? Well, today we're diving deep with Steve Younger. He authored WWT's research paper, Why Kubernetes is the Platform of Choice for AI. Steve's been here before discussing cloud-native development, and now he's back to explore the Kubernetes AI connection. Get ready to discover how Kubernetes is revolutionizing enterprise AI deployment. Welcome to Worldwide Technology Presents Research, insights powered by the Advanced Technology Center.
WWT presents Research.
Steve, this is not the first time we've had you on the research show. In fact, we were just talking cloud native, it feels like yesterday, although it's been months. But either way, this is not obviously far from your expertise. First of all, welcome to Worldwide Technology Research.
Thank you.
It's good to have you here. And I'm fascinated. You wrote a paper based on your argument for why Kubernetes is an ideal platform here. But for anyone who's not familiar with you, do you mind telling us who you are? What do you do for Worldwide Technology?
Yeah, so I'm a technical solutions architect within our global solutions and architecture team, or GS&A. And my role is on the pre-sales side to help support the field and our partners with delivering public cloud solutions. And that's the team that I'm actually on, is for public cloud. But okay, my subset focus is cloud native platforms. So I deal with helping customers move to a cloud native readiness posture. DevOps is a little bit in there, but not a lot. It touches it. A lot of containerization, Kubernetes, a lot of trying to figure out which applications should run within containerization versus should be run as VMs or bare metal, and where they should run, whether they should be running in a public cloud or on-prem, and just kind of being that guide for customers to try and educate them and help them, because cloud native is kind of a buzzword. It gets thrown around so many times and so often that it's like AI today. It's just AI is the new word. So you have to say it so many times in meetings, and it's kind of lost meaning, or it's kind of blurred the lines.
Sure.
And it's my job to kind of help customers stay on track and keep moving in the right direction so that they can get the benefits that cloud native offers.
Well, good, because I'm definitely someone who even just messes up some of the terminology sometimes, where I'll conflate things that shouldn't be conflated. So you wrote this paper kind of promoting the idea of Kubernetes as being ideal for a lot of the challenging things that a lot of customers are really running into now when it comes to AI workloads and how different, how unique they are. What was the genesis of this idea? What caused you to go down this path?
Well, like everybody in IT, we're all asked to explore AI and kind of get a handle on it and understand the impacts around the business and the technology stacks that we deal with. So when I began to dive into that, I noticed a big surprise, just a surprising gap in all the articles, the meetings, the podcasts, YouTube videos, everything I was trying to scrape for to come across. I found there was little to no discussion about the underlying platforms that AI is actually running on. Everyone was talking about AI models, algorithms, applications, and everything around it, but not the infrastructure that supports them.
Which seems kind of important. Yeah.
I thought it was. And I was surprised that one of the first things that I did learn when I started to look at AI, that it basically all runs on Kubernetes for the most part.
Yeah.
But it's not very well understood still to this day. So given my background with covering Kubernetes directly, I just realized this was an area that I could contribute to. So I decided to approach AI from a learning perspective on my own, but also from projecting out to customers and to help them, is just taking it from the platform and building up from there. And I think that that's just a way to shine a light that Kubernetes is well suited for AI workloads. I think it explains at a high level why Kubernetes is so integral and maybe even helps customers understand why AI runs the way that it does, and maybe kind of put those pieces together.
For anybody that may not be familiar with just what is Kubernetes, I think a lot of people go, Kubernetes, that's something to do with containers, right? Can you define Kubernetes as it's important to level set for this talk?
Yeah. To understand Kubernetes, I think that it always helps to kind of look at how computing has evolved over time. So starting with bare metal servers, just imagine that you have a dedicated house for a single family. Each server, like a house, is built for one purpose, hosting everything in one place. So that's very stable, but it's not very flexible or scalable. So we needed a way to increase workload density and to begin to address the scalability issues. And virtual machines were kind of that answer as they came onto the stage. Sure. So now imagine that you have a large apartment building. Instead of individual houses, you now have apartments that function independently, much like a virtual machine, allowing multiple families or applications to live in the same building, which is the server, while sharing resources more efficiently. With virtual machines, the scalability issues began to be addressed by increasing density, but they didn't really solve the flexibility problem, and that's where containerization comes into the picture. Containers are lightweight, and they allow for quick deployment and scaling of the applications. Now, by being lightweight, all that means is that all of the dependencies that are only required to run that application or for it to do that task or job are incorporated into the container image. Okay. No other fluff is there. So like a ping command and things like that, those packages, they don't exist inside of these if those tools aren't needed. So it makes it lightweight, so it's very small, so it can deploy more quickly. We've addressed flexibility and scalability issues with containers, but now we have to have an efficient way of actually managing all of these containers. And that's where Kubernetes can come in. So imagine that you're not just managing one building or even one city, but an entire network of cities. Each of these with their own apartments and shared houses. Kubernetes is like a city planner and a manager. So it just makes sure that everything is running smoothly across all the cities. It automates the deployment, the scaling, and the operations of containers. So this just ensures that each application can get its own resources that it needs without any additional waste. So it can dynamically scale and be deployed as needed with only the small millicores of CPU and of megabytes or even gigabytes of RAM, depending on what the application or job is. Yeah. And that makes it lend itself very well to AI.
Well, and in that, there were some specific things that you called out in the paper about Kubernetes, specifically some features like auto rollback, self-healing, the ability to scale, both at I think at the pod level as well as the cluster level. I wonder if you can talk about some of these specifics that you'd covered in the paper, because I think they're interesting and because they're kind of natural abilities, I guess, of Kubernetes that are just part of the way it's designed.
Yeah, so scalability is inherently built into Kubernetes. That's the way that it was designed from the ground up by Google in the early 2000s. They needed a way to scale and manage, tens of thousands, hundreds of thousands of applications. So that's going to be built in natively. So at the pod level, you have horizontal pod autoscaling, vertical pod autoscaling, and all those things mean is, so horizontal pod autoscaling is allowing you to have what they call replicas. So let's say I have one website, one web server that's running, and as load starts to pick up on it, you run a sale or a nice marketing campaign comes up and it starts to get hit with more load. You can tell it to automatically scale based on the resource consumption so that it doesn't lag behind, and you can offer your customers that good experience. So it'll replicate itself to 2 to 4 to 8 to 16 to thousands of pods. And all of the networking and everything is automatically plumbed as it gets deployed through service discovery and other mechanisms. And then you have vertical pod autoscaling, which allows you to dynamically scale a pod's resources, so CPU, memory, and now with AI, GPU, how much you assign to each pod, so you're not increasing the number of pods, but you're just making each pod larger. So that addresses some of the scalability things that are native to Kubernetes around the pod directly. At the cluster level, we have cluster autoscalers, and cluster autoscaling does similar to what the horizontal pod autoscaler does. As you have a cluster of a set site of what they call worker nodes. So that's the number of servers that you have running, and they can be virtual machines or bare metal. And let's say that you have 10 of them that are running, and additional pods need to be scheduled. And as they're being scheduled, the scheduler within Kubernetes sees, we're running out of resources. Then something like a managed node group, if you're in a public cloud, could recognize, we need more resources. And it will provision dynamically additional nodes based on parameters that you set as an organization, so that it doesn't go crazy and scale tens of thousands of nodes, but you can set it to scale up to, say, 100 nodes and scale back. So it'll start to provision these virtual machines or these bare metal servers, and they'll incorporate them and add them as additional workers to the cluster. And then as it does that, you now have a larger available pool of resources, and the Kubernetes scheduler can see the availability and start to schedule those workloads as it needs. And the great thing about that piece of it is that the cluster autoscaler, people think of it from that point of view of, it's awesome. I can go up and I can burst and I can have it dynamically be elastic. For me, I think the really cool thing is that you get to save some money, because you don't have to have somebody sitting there as an admin and look at resource utilization across graphs and think, I think we might be able to move some workloads or something and delete some nodes. It'll automatically kill the workloads that you have. And that's a part of a cloud native principle that enables that feature, that allows that your workloads can be treated like cattle as opposed to pets. That's something that maybe people have heard of with cloud native. We talked about that a little bit.
I remember learning that one from you. Yeah.
Right. So they're allowed to be killed and just brought down immediately, that are working on that worker node. And then they can be rescheduled automatically without disruption. Because again, we can have multiple replicas. So let's go back to that web server analogy. Let's say that we have 3 web servers that are up and we only need 2. Well, we still have 2 others that are functional. So when we kill one, the customers are still going to web server 1 and 2, but 3 is now no longer available.
Yeah.
And then once that Kubernetes node is no longer used anymore, it can be deleted. And when it's powered off and removed, you're no longer being billed for that if you're running in the public cloud, or you're reducing your energy costs because you've shut down that node.
You speak of in the paper, and I hope I'm saying this right, but the notion of resource constraints and being able to program those in here to keep, basically have it operate within certain parameters.
Yeah, so within a pod manifest, so it's definition file of parameters of how it's supposed to run and where it runs and what resources it needs, you can set resource requests, which is kind of like in the virtual machine world of saying, I need 3 or 4 or 5, whatever vCPUs, and I need 4 gigs of RAM. So that's a request so that it gets scheduled on a node, so a worker that can satisfy that. And then you can have a limit that's put in place as well to control that pod so that it can't exceed and then overrun that node. That way we kick in pod auto scaling and things like that. That way we're staying elastic, but we're not overwhelming. And that makes it a lot easier to manage the life cycle of your applications, and allows the infrastructure teams to breathe a little easier, because they can kind of expect, okay, these are the maximum limits that are placed on all of the pods that we have within this cluster, within this particular region. So we can estimate that it's going to cost around this at most to run. And you can kind of do projections, and you can create graphs that you can monitor what's happening, and then you can make more informed decisions.
The nodes that are chosen could have different services attached to them or different capabilities. And especially when we talk about AI, a lot of times we're always talking about GPUs, even though CPUs are still very much in use. But you could have GPU-enabled nodes, and you've kind of outlined some tools that NVIDIA makes available to kind of make that process easier.
Yeah, so every node that has in the public cloud or in your own data center is going to have different resources, right? They're going to have different number of cores, different amounts of RAM, different storage performance. And those are all things that are familiar with people within virtualization with typical VMs. Within containerization, that's also still true. And then you can also deploy a worker or workload onto a worker that has a GPU. And to make sure that you do that, you have to load the drivers for that image, right? So that's not going to be the same as it's going to be for a node that doesn't. So that may be another image that you have to keep on-prem. And like, I have to deploy this image as opposed to this golden image when I spin up this worker node. because of this GPU. But I have 8 different types of GPUs, so that's 8 different types of drivers. So it makes it a little bit more difficult. So NVIDIA created a GPU operator, which is really cool, and it deploys as a pod. It's multiple pods in Kubernetes, and when it deploys, there is a workload that discovers all of the workers and just looks at them and says, which one of you has a GPU? And then when it's, oh, well, you guys have GPUs. So then it's going to spin up another workload, so another pod, and it's going to run directly on those workers only that have a GPU. And that's loading the drivers for that particular NVIDIA card automatically for you. You don't have to have an additional image. So that allows you and your security team to breathe a lot easier, because now you have one golden image that you can operate from for your entire cluster. It can stay immutable, so there's no updates or anything done to it, because you just roll the upgrade completely by repaving that worker each time you do an upgrade. You don't have to sift through and make sure that you're getting everything. The other cool thing that it does for you is the GPU operator, when it discovers that there is, say, an H100 on node 16, it'll look at that and it will actually annotate, it'll label that worker node as having an NVIDIA H100 GPU. And then that label can be used for scheduling decisions. So then your development team, or the people who are running on the back end, your data scientists, whoever's deploying these AI workloads, they can leverage that label and say, well, no, my workload needs an H100. I can't use these other ones that you have that are older or whatever. And then you can say, well, I need an H100 and I need 4 of them. And then you can map that out. And then the scheduler can then go and place that workload on an appropriate worker node that actually has an H100. So it's a lot more efficient that way.
I feel like we tend to think of things still as monolithic applications, and kind of the contrast to what you're describing here would be having to build a new version of a big fat application to take into account some of the variables you're talking about here, versus it sounds more like now we're setting up a structure to where situation, context, if you will, for any given thing happening is going to be combined with a set of rules that say you're going to need these things, and then it goes out and kind of does that based on that structure that you've set up, so that it feels that's part of where it gets a lot more flexibility. You kind of have these scalability and resource management, I think, is kind of where you encapsulated this part of the conversation in your paper.
So what I'm talking about is from the infrastructure side, on the infrastructure layer, and that allows for the infrastructure team to better manage the clusters that exist, to be able to support the developers to run their AI workloads and tasks. The other side of that coin that helps, that where Kubernetes is really beneficial to running AI, is the developers, when they go and they deploy an AI model, or they want to train something or do something, there are unique libraries that are required that are specific to that model. So different Python versions and libraries, TensorFlow versus PyTorch, and some of their dependencies that exist. And it's very, very nuanced. And I am by no means an expert in AI. I'm not a data scientist. But my understanding of when I was looking at it is it's a little bit of an art as well, with trying to develop these models and make them effective. So you need to be able to iterate quickly and see the result of what your work is, so you can look at your masterpiece, I guess, if that's you want to look at it with art. And you need to be able to come through and go over and over again and iterate, and be able to make those dependency changes quickly. And you can't really do that or scale that kind of thing in virtual machines very well, because you'd have to have a virtual machine image, which is large and takes a while to deploy for each one of these. Whereas you can have these dependencies injected into the image as it's being built and moving through your pipeline to go get deployed.
When we talk about kind of a GitOps structure in terms of specifying the outcome that you want, not how you get there.
Yeah, it's a declarative model within Kubernetes. So you're not specifically telling that worker or that machine, I want you to run this command and then this command and then do this to get there. Instead, you just say, I want you to run this. Yeah. You go do it. You figure it out. I'm not going to deal with that. And that really makes it a lot easier for, Kubernetes to maintain state, so it can keep an understanding of what it's doing, because it's the one doing it. And then you don't have to stress about the details and the specifics, because at the end of the day, if you're a developer, regardless of what you're writing and what you want to be able to publish, you just want to run it and see that it works. You don't want to deal with the underlying infrastructure that has to go underneath to keep it running.
Yeah, there's always going to be a big difference, I guess, between the people who make something and then the people who are using the thing. And you're going to have a limited knowledge when you talk about scaling people that just need to tap into a system that's ideally got enough guardrails to keep them from messing things up, but at the same time limiting what they have to be responsible for, I guess.
And you want to keep your developers happy and make sure that there's as little friction as possible to help them be productive and be able to develop on and deliver their product on time.
So you had an e-commerce example for kind of explaining how these components work together, at least to the extent that we've discussed them so far. Do you mind running us through that?
Yeah. So you have an AI model that's performing recommendations. So a recommendation engine for your customers on whatever it is. So on clothing or something like that, for picking out accessories, whatever it is that your company does. And that model is able to work with you in doing inference by making these recommendations. But during peak demand, so in unusual times, that you're not going to buy hardware for the peak, we're going to buy hardware and scale for the day-to-day operations. So Black Friday, say, comes around, that's a major shopping event. During that time, your cluster is going to experience very high demand, and your AI model may get overwhelmed, and you need additional hardware. So that's where we were talking about that cluster autoscaler earlier, but on-prem only. You may not actually have the hardware on-prem on hand to be able to handle this, especially with the GPUs and stuff that you may need. So the cool thing about Kubernetes is it's completely conformant, which means that it doesn't matter which implementation of Kubernetes it is or where you run it, as long as it's conformant means that it's the same Kubernetes that's deployed everywhere. So there's no closed source or anything that's hiding or that will break it. So you can run your cluster on-prem, and then you can pick the public cloud offering of your choice that you're most comfortable with, and then you can burst up to the public cloud and you can consume their resources. So in AWS, for instance, you can ask that to spin up some EC2 instances with GPUs that are required for your model. And then with that, the NVIDIA GPU operator can automatically be extended up there that we talked about. It'll scan those nodes. It'll see that it has the GPUs that you need, that you've told it to deploy. It'll label them automatically. And then your workload through horizontal pod autoscaling or through other mechanisms within Kubernetes that you may be offering through third parties like Run AI or something like that, it could then scale out and start expanding and deploying or scheduling additional replicas of your AI workload up into the public cloud or closer to where your customers are so that it can serve what they need. And then you're not on the hook for buying all of this hardware during this very, very, very peak unusual time, which may only last hours or a couple of days. And then you can scale out and use the resources available to you for that public cloud as needed. And then as the resources get consumed, customers fall off. We're past Cyber Monday. It's now Tuesday, Wednesday. We're getting into the week.
Yeah.
Those nodes that are managed node groups can start scaling down automatically. And as you're dynamically scaling with demand, maybe overnight, it scales down to save you money because GPU instances are both scarce because they're very, very well consumed all the time. Sometimes you can't even get a GPU worker depending on what time of day or what part of the cloud. So you can scale automatically so that you're not consuming those resources when you don't need them. So you're not being charged for them. And then you can start back over again all over, and you can burst back up again as your workloads demand.
And that's really that portability and flexibility that we're driving for in the Kubernetes environment, right? Which is because to get to that point, is it correct to say that you're developing, how would I say this, in a cloud native fashion? I mean, these are cloud native principles.
Well, Kubernetes itself is cloud native in the way that it was designed and built. So that's where it allows it to run anywhere. That's that portability piece. The cloud native aspects of it would be allowing your workload to be killed, like we were talking about with cattle versus pets, where it can just be shut down immediately. And you have to code for that. That's not something that is just, I don't need the application anymore and just destroy it. No, your developers have to allow it for it to gracefully shut down in some way as it's getting that signal that you're no longer going to be running. that would be where those cloud native principles come into play.
I know that these are early days. I don't know that you've run any costs against this, but you foresee kind of a reduction in capital expenses being enabled through this type of architecture?
Well, if you're running AI workloads, that's a different kind of workload. So you're introducing additional hardware, additional cooling, additional electricity usage. So your costs are going to go up, but we can mitigate how fast they go up, and we can control that through responsible structures. So we can make sure that our clusters are scaled properly, that our pods have the appropriate resource requests and limits that are placed on them. And those are all best practices of a cloud native mindset. So by doing those things and embracing those FinOps, there's another catchphrase for you.
Yeah.
It's even if you're doing it on-prem only, and you're like, I'm not using the public cloud, I'm not billed by the hour or anything, you still need to be responsible and efficient with your resources, because you may have team A and team B that are developing AI models, and they need access to those limited pieces of hardware, because GPUs are very expensive. You can't just throw them in all of your nodes throughout your data center. That would be cost prohibitive. Cooling would be an issue. Electricity would be a serious issue that we can't really get into here. But those are the unique challenges with those. So you really need to be responsible with that and have schedulers in place. And that's where Kubernetes being extensible really comes into play, because there are so many third parties out there that exist. There's the CNCF landscape that you can go to, and you can see this plethora of organizations, nonprofits, products that are out there that address any gambit of issues that you may have. And one of those is already within the data science area and MLOps. Run AI, I've looked at quite a bit. It's very fascinating. NVIDIA acquired them, I think, earlier this year.
Talk about what they're offering, because they're helping. I think you said fractional GPU access, which is something that wasn't possible without Run AI before anyway, even though now it's obviously becoming more. Am I saying that right?
Yeah. So typically within Kubernetes natively, you can do fractional CPU, right? So you can say, this is how many millicores that I want. You don't consume the entire CPU. And same with RAM. You can say, I want this many megabytes, all the way down to that size. But with GPUs, it's just a 1, a 0, I need it or I don't, or it's 2, I need 2. And that consumes the entire GPU and just passes it through on that node to that pod. And that's not an efficient use, because
it would be unavailable for everyone else, correct? Even if you didn't need all
right.
of that. Yeah.
And your model may not require all of the GPU power that it has. A lot of these new GPUs that are enterprise level are massive. They have so much RAM and all this power that your one model may not need. You may only need half of it. Or you could say, well, I only need 40 gigabytes of RAM, of GPU memory. And that's it. And Run AI actually preempts the Kubernetes scheduler. So that scheduler I was talking about that looks at the worker nodes and says, I have a new pod coming in that needs to be placed. It looks for the labels and it looks for things to place. Well, Run AI actually preempts that scheduler for this, and it'll take your workload, and then it'll say, okay, well, we're going to place it over here, and we're going to give you 40% of this GPU.
Oh, wow.
Spread across X number of nodes. So it'll actually do multi-node, multi-GPU sharing across nodes, which is really cool too. And that also introduces additional libraries and dependencies that have to be written into your model, so into your container, that are unique. And again, that's another reason why you have to really make sure that your image is small and scaled appropriately for your AI workload.
Well, what's the importance of understanding federated clusters?
Yeah, so federated clusters just allow you to loosely manage multiple nodes spread across geographically disparate areas. Okay. So you can have it running on your on-prem solution, and then you can have it running in an availability zone in AWS, and then you could have another one that's running in Azure, and you can keep those separate and based on where your customers are and where you need those workloads to be running. And that can dynamically scale as work is needed.
Well, and it was kind of in that same area you talk about, because it seems like this would be a major hiccup, but it's access to storage. We're dealing with so much data, especially at different phases of this type of process. When you go from maybe training and you're all the way to inference, or your data needs are going to differ.
Yeah, so that's part of it being a compliant Kubernetes is being compliant. So we have a CSI standard, so that's for storage. And then there's a CNI for networking. So these are all standards that are written, and they're all open. So you would have a driver for a CSI driver for whatever storage you have, and that's obfuscating whatever the underlying storage actually is. And then you have a persistent volume that's presented to those pods, and that's what your workload gets to see. It doesn't get to see what the underlying actual storage rate is. So that allows you to move it wherever you want without really a whole lot of issues.
Can you explain where operations and how this kind of changes things? Because you bring up in the paper CI/CD. I'm not sure if anyone's not either watched our other shows or may not be familiar with it, but continuous integration, continuous development. But you're proposing a third kind of loop that's within this as well to keep this type of thing on a recognizing the cycle of iterative improvements, I guess.
Yeah, it's not from me. It's an industry thing of continuous training. And it just basically takes the CI/CD pipeline that you see, that infinity symbol, and it just adds a third loop over to the side. So it just integrates the machine learning aspects of continuous training, because as you deploy an AI model, it's not going to be static. It can't just sit there because information changes, additional information becomes available, new training methodologies become available. So you have to be able to iterate and retrain on that. And one of the ways that you can do that is just to have an automated pipeline that's set up for existing models and just say, hey, once we get a critical mass of new data that's been pre-processed and everything, automatically kick off a new training job. And then it'll go through that CI/CD loop and move through, just like DevOps principles where they walk through a CI/CD pipeline. That same thing gets extended into MLOps.
In their 5 more reasons, you'd mentioned kind of community and the ecosystem. You mentioned Run AI as being part of that ecosystem. Are there some others that you found to be important and why in terms of how Kubernetes provides support in this area?
Well, within the ecosystem, there's been a lot of standout players that have come to fruition. So Prometheus is really good for monitoring and alerting. That's become kind of a standard. So that's implemented very well to be able to monitor GPU usage. Run AI can leverage that as well as any of the other MLOps platforms that integrate with Kubernetes. And then you can use Grafana, which is also very popular and prevalent, to be able to see and visualize the state of your cluster. So all of your resources being consumed and your costs. Other things that you can do, implement service meshes for increased security. With AI, it seems like it's a little bit of a black box for a lot of people. It's freaky how it works. If you've ever interacted with even ChatGPT, it's amazing how smart they are, and I can't explain how it actually is able to do all the things that it does. And I think that adds a little bit of apprehension to companies when they say, okay, so I'm going to give all of my personal data, our trade secrets maybe even, and we're going to put this into this model to be able to churn out to get the information and make this useful for us. Well, I want to make sure this is as protected as possible. So service meshes would probably become a good conversation starter. And that's where you can encrypt traffic from pod to pod. So even within the same worker node, so if it's running on a public cloud and you don't own the infrastructure, it's still encrypted before it even leaves the pod, let alone the worker itself. So everywhere it's encrypted the entire time. You can then have additional sidecars that give you traceability. So you have visibility into every single aspect, every trace, every API call that's being made within your AI models, to take a look and see if there are bottlenecks, if there are failures. You can put in circuit breaking. That's a really popular thing with service meshes as well. So if it can kind of pick up the slack if there's some coding issues or if it's not optimal and it's getting overrun, you can put circuit breakers in. So it's a little bit of a delay. Like, okay, I know you've asked already 5 times, but let's wait a second. Yeah. Let it clear out the requests on that pod. Okay, now let's send more data to it. Those are things that are native to Kubernetes. People are very aware of these things that are within Kubernetes. And I just think that it reinforces how important it is to understand those technologies and to implement them to make your company feel safe and make them feel confident and have visibility in what is actually happening for this new type of workload that they're all now having to figure out how to do with.
Yeah, well, because I feel like security is probably already top of mind for anyone that's doing their own model. And as you talk about cost benefits of being able to use your public infrastructure uh, in a bit more proactive way, how set up are the public cloud providers for being able to let you work in that same fashion?
Yeah, so if you're running a Kubernetes cluster yourself on-prem, and then you decide to burst to the cloud, or you just want to extend to the public cloud and use it daily, it's going to be the same. It's still, at the end of the day, it's underlying compute. They just call the compute something different, be it an EC2 or just compute or an instance. And then you would pick that with the vCPUs, the RAM, and then in this instance, the GPUs. And every public cloud provider is working as fast as they can to accommodate their customers and deploy as many GPUs as they can across all of their regions and availability zones. It's tough. I mean, everybody wants something, they can only make so many and so fast. But if you're just running Kubernetes and you want to be able to move to the public cloud and extend what you're doing already, it's the same language and everything is the same. The public cloud does offer some other cool things that a lot of people are really taking advantage of with some of these SaaS offerings. I am not an expert in these offerings, but we have a team of people that I work with that are dedicated to each individual public cloud, and they can talk to you about Vertex AI and SageMaker, which is an MLOps platform within AWS. And those things really allow for a little bit more of a plug and play, a little bit of a walled garden where you can pick a model that you want to try out and you can get comfortable with AI and you can move through and use the public cloud without going to your boss and saying, well, I think we need to start running AI workloads. Oh, well, I need all of these GPUs, all of this hardware. Oh, by the way, I need like 6 more air conditioners. We don't have that either. It's a tall ask. So the public cloud is really getting leveraged really hard for use case discovery and for being able to see the capabilities of what they can do. And each of these public clouds have phenomenal product offerings that offer simplified, approachable ways to deploy your AI models and train and do whatever you need. And they're there to help.
Are we getting closer to, I don't know that it's our nirvana per se, that was the wording I was going to use, and I think that's a little bit dramatic, but this notion of, are we getting closer to being able to write once and use and not have that fear that you're going to spend a lot of time developing something that has a limited shelf life because things change so quickly?
No, I would say that that's true with moving to containerization or to a cloud native principle or a cloud native mindset to begin with. If you don't do that, you can stumble and then you can cause a little bit of headache, additional cost and overhead that you don't need, and maybe some inefficiencies that get built in that maybe you didn't intend. With AI, it is more expensive because now we're dealing with the GPUs. So it's the hardware, it's the cooling, and it's the electricity. So I think you have to really come out with your best foot forward and understand, I have to do this right from the beginning, and we have to use best practices of cloud native, of MLOps, and we have to establish these pipelines that are appropriate for doing this the right way the first time. Otherwise, you could just sit there with a public cloud cluster that's running and it never scales properly, and you're just sitting on dozens of nodes that are GPU enabled, and they're costing you X number of times more than they would if they didn't have GPUs in them.
Is there anything else that you think that either I forgot to ask you or you think is important to remember as we're leaving here?
It's still changing and evolving very quickly. Kubernetes version 1.31, I think just got released last week, and they're now starting to create that OCI compliance. So I was talking about that CSI standard and the CNI standard where they're standardizing on things. Well, they have the Open Container Initiative as well. I hope I'm getting that right. And that's also standardizing on containers. Well, they're standardizing now, and they're starting to incorporate things around AI. So around libraries that you're going to be consuming and around GPUs that you're consuming. So things are starting to be built around, and these frameworks are being built, and they're becoming a little bit more mature each day. So it's important that you're deploying in a way that allows you to adapt to those changes so that you maintain a competitive edge and you're efficient.
Can you talk a little bit more about what WWT resources exist now possibly some I bet you're working on right now. Because I've seen Kubernetes 101 that you guys offer as a remote lab. Actually, it may not be a lab, but I know you do briefings in various topics around this. And then you are specifically taking some of this material and continuing to mature it with your teammates as you push through additional development on this. Is that correct?
Yeah, so if you're at the beginning stages, you're a virtualization shop and you're looking to move into containerization, we can help you from those very beginning stages by helping you rationalize your applications, by walking you through a cloud native readiness assessment that we offer to be able to just check and see how you are and maybe be thought provoking to help you understand where you need to go. And then along with that, we have full coverage for all of our public clouds. So AWS, Azure, Google, and those TSAs can walk through with you the benefits of each public cloud and how they can onboard you. They can walk through migration strategies with you and look at your workloads so that it's tailored to you. It's not some cookie cutter thing, and it's rational. There are milestones. You can see where you're going. It's not this endless loop of, oh my God, am I ever going to see the end of the road and be able to do this? And if you're already there, you're already cloud native, you're already consuming the public cloud, and you're just wanting to use AI, or you're just wanting to use AI to begin with, we have AI workshops from ideation to help you work through how is it that I'm supposed to consume AI? I know it's awesome. I know it's important. My company has to use this in some way. We can sit there with you and work with you to figure out what's going to work for your industry and your vertical. And we have experts in these verticals that know your industry that can help work with you. And then beyond ideation, we have other workshops to help you to be able to demonstrate Gen AI, vision, all of those things, RAG, retrieval augmented generation, which helps with AI models. And we have these demos that are real life, and they're not just a chat bot. That was done last year. That was cool. These are more refined.
It feels like we're going to see a lot of AI, and I think we already are, is really where we're not seeing it, in terms of end use, because it's working and it's improving things in ways that may not be immediately obvious from the consumer side in this, because it's not a big blank box where it's like, I can answer anything, but you need to ask me as intelligently as you want your response, and some of those tricky things that can really throw people off. But Steve, as always, I learn a ton every time we get on together, and I appreciate both what you've written and what you continue to work on here. I hope we can touch base on this again, because I think it's going to mature quickly. But thank you for joining us.
Thank you.
I believe that Steve has made the case. Kubernetes is the leading platform for AI at scale. Its scalability, flexibility, and robust ecosystem are answering critical challenges. From efficient resource management to smooth MLOps integration and storage security, Kubernetes delivers. For organizations scaling AI, it's become an essential tool. As artificial intelligence progresses, Kubernetes is well positioned to shape AI infrastructure's future. Well, we've dipped our toe into Kubernetes today, but there is an ocean to explore. I encourage you to dive deeper with Steve's paper, Why Kubernetes is the Platform of Choice for AI. But if you still want more, there's hands-on labs, expert-led group sessions. At the very least, I encourage you to register for regular updates on the solutions page. Follow us to stay ahead of the Kubernetes AI wave. I'm Rob Boyd, and thank you for joining us for another WWT Research presentation. There is a lot more coming your way, so stay tuned for our next insightful episode. The world of AI and Kubernetes is constantly evolving, and we're here to guide you through every deployment.
This episode is brought to you by Veeam. Data disruption happens. Veeam ensures data resiliency for your business through secure data backup, fast and reliable recovery, and data protection solutions for cloud, virtual, physical,